Welcome everybody. We'll start today's session on Introduction to Red Hat Storage. I am Saha. I run product management for Red Hat Storage, for our Red Hat Storage portfolio, based out of the Boston area actually, so it was not too hard for me to come here. Unlike Vijay Bellur, who came all the way from Bangalore, he's a tech lead for Red Hat Storage based out of our Bangalore Design Center. He came from the Gluster acquisition. Myself, I came from actually Red Hat, didn't come from the Gluster side. But I've been in Red Hat before, more than 2 years now. And before this, I was responsible for managing the storage and the clustering portfolio of Red Hat Enterprise Linux. Vijay, you want to say a few words for yourself before we start off?
Hey, as Sayan mentioned, I work out of the Bangalore office, and I am the technology lead for Red Hat Storage 2.0.
So today, our plan is not to have a Q&A session at the end. If we can answer most of your questions right here, we'll actually keep a tab on time, but we want to keep the session extremely interactive. So if you have any question, please feel free to interrupt us any point, and we will try our best to clarify. If we see that there's a topic that needs more detailed discussion, we might want to do that offline. But we are here to answer all of your questions, not go through 24 or 25 slides that we have. That's not the point here. But rather, when you go away from this session, you have a very good grasp of what this is all about. So with that, I'll start. My presentation outline is what is it? What is Red Hat Storage? How many people in this room actually heard about Red Hat Storage before you came to the conference? Quite a few. How many people actually knew about Gluster? Pretty much everybody. So that's a good start. So I don't have to waste too much time on explaining what is it to you, and then give that to Vijay so that he can tell you the useful things. So I'll take you over what is Red Hat Storage, what are the design tenets, what's the technology behind this product, how do we actually productize it in Red Hat, what do you buy, if you ever want to buy anything, what do you buy? What was the focus of Red Hat Storage 2.0? Now, I don't know if you have looked at your emails, but we did announce Red Hat Storage 2.0, our first ever big launch from Red Hat that GA'd yesterday. So we want to basically let you know basically what we have today, what's in the truck. That's that. We'll give you a glimpse of the roadmap, but for the full roadmap, you need to bear with us and come back to another session, which we'll have in room number 306 at 4:50 p.m. today, where we'll go over detailed roadmap and future direction. So that's going to be a very interesting session with me and co-presenting with a lot of our Gluster developers from Bangalore. So that's going to be very interesting. And then I'll conclude, and then hopefully have another QA, have time for QA. So with no further ado, I go on to my next slide, which is the definition of what it is. It's a marketing definition, just, I raise my hand and tell you, but most of it is actually true, for a change. So, so it's actually open, unified, and extensible scale-out network storage, a software solution for pretty much anywhere you can want to deploy it. So you can do it on-premise, in your private cloud, public cloud, or in a hybrid setup, and we can do that. So a picture speaks 1,000 words. So what does it, what is it really, So basically what we have got here is the 50,000 feet overview of this storage product or technology, where you have disparate set of physical machines that have disks or JBODs attached to them. And we have the Gluster distributed file system that spans across those and aggregates the storage that's in each physical box to export a common mount point which you can access via NFS, CIFS, Fuse, or OpenStack Shift. So that's the core 50,000 feet, and we'll drill down into more details as we go on. But this picture actually is a picture that we use in the Gloucester community also, and it's a good one to give you a sense of what is it. So let's go to where we started and why we started this in this route of taking on storage inside of Red Hat. So a little bit of backgrounder, as I might want to call it out. So what we noticed in the last few years or so is there is an explosive growth of unstructured data in the world today. And by any means, they're like more than 50% of the data that an enterprise has today is file-based. Roughly 25% is email-based, and the other 25% is database. And that 50% is growing very fast. It's not stuck at 50%. We also know that almost 90% of the data that exists today was actually created in the last 3 years. So that goes to show how big that market and how fast it is growing. Yeah, sure.
Quick question. Doesn't unstructured data really mean not relational structured data? Unstructured data has quite a lot of structure which needs to be exploited.
Right, but not in the traditional sense of a relational data which has rows and columns.
I agree.
Yes.
But on the other hand, it has a lot of structure. In the memory, you tend to know where the address is and where the signature is and things like that.
Yes, but the definition of unstructured data where we are talking about here is mostly file-based. Your MP3s, your images, your JPEGs, your text files, your whatever that needs to go somewhere. And using a relational database to hold that is not a wise investment. Exactly. So yeah, if you look at lots of data, there's unstructured, there's semi-structured, and there's structured. So semi-structured data is like log files, So that's another way. So when we looked at the market, we saw what storage solutions existed, and mainly traditional storage solution solved a lot of very good problems that were needed to be solved. However, when it came to unstructured data, they fell short. Most of them fell short because most of them did not do a very good job scaling out. If they did scale out, they had a metadata server which led to a single choke point or a single point of failure. They were storage silos that were getting built in enterprises where you had NAS, you had SAN, you had object, and for each application that you would build, you would actually have to think about what kind of storage you needed beforehand and do. So what you ended up in 10, 15 years is many storage islands which are kind of disparate in nature. Scale-up storage, which is our traditional storage, shared all architecture, eventually hits a wall. It just can't scale out beyond a certain point. So using a scale-up storage solution for unstructured data fundamentally is not the right way to go. Plus, you had the unpredictable costs of where you had to upgrade every 3 or 4 years when the vendors released a new configuration or a new controller, and you have to go to that one. So you couldn't kind of scale on demand. It was always, you had to plan in advance and make sure that you have optimized for the best performing workload, the most storage space, and then eventually, you'll hit a wall and you have to do the next thing over and over again. So when the Gloucester creators or the Red Hat Storage initial creators set out to do this project, they had a few things in mind they wanted to solve really well because they noticed the pain points that were there in the market today. There were scale-out technologies out there, but most of them had a metadata server, which led to basically a single point of failure or a choke point. So you couldn't scale out without a bottleneck. A lot of them or most of them did not have any elasticity. So when you had to scale on demand, that is add more storage to the pool or delete storage from the pool, you would have to impact the application, which for an enterprise today is not the best choice because you hardly have any downtime. You need to be running all the time. They were not deployment agnostic, so you could put them in your data center but not in the cloud. You could put them in the cloud but not in the data center. It's like you couldn't just take it where you wanted. Your data was kind of captive to where you wanted it, to one place, and then moving it back and forth was hard. Linear scaling was something that you could not achieve because fundamentally how traditional storage is designed is you have storage boxes and you can add more disks to it, but you don't change the processors that go with it. So while you add more capacity, you're still stuck with the old processors as opposed to adding a new server with processors, which helps you scale linearly. And the other thing they never did was it was all appliance together, bundled together as one appliance. It was never running on community servers, so you couldn't pick up your favorite server vendor and run this software on. So these were the additional goals. So we wanted to make sure the Gluster developers or the original architects made sure that they addressed the pain points with these design tenets. So what do we have today is in Red Hat storage, basically something that has solved quite a few of the problems or the initial pain points that we noticed. So we have a highly scalable storage cluster that actually has theoretically unlimited scale. But although it's theoretically unlimited, we do, for supportability reasons, we have a limit to it, but there's nothing in the architecture that prevents it from going beyond that. But we try to test what we support, so we have a limit. It's highly cost effective. You can buy your industry standard community servers and you leverage your existing capacity in the VMs and you're done. You don't have to get special purpose hardware with ASICs to do this. It's highly flexible. You can deploy it anywhere, physical, virtual cloud, or hybrid. And it offers file and object access protocol, so you don't have two different storage islands. And it's open and standards based, so you don't have to deal with some proprietary hidden secret sauce. So everything is NFS safe HTTP, well-known protocols that you use every day. We support all of that. So what are some of the technology highlights? So single global namespace I already talked about in the first slide. So that's very good. You basically take a bunch of servers, aggregate them together, export it with a common mount point, and you can do that very easily. It's very fast. It is software only and it's open source. And it's also user space, which actually gives us a lot of degrees of freedom. We don't have to wait for kernel merge windows to open to add a feature. So it's very easy to add features, attract developers, and install and upgrade. That gives us actually a lot of degrees of freedoms. It's very simple and extremely easy to use. I come from a scale-up storage clustering background, and I know how difficult it can be to set up a cluster or a clustered file system on top of it. This one is the exact opposite. You can set up, in 10 to 15 minutes, petabytes or I'll say terabytes of storage. It's so easy. You just have to use like 4 commands and you're done. It offers unified file and object, which is basically an object interface as well as a file interface. So you can write using the object interface, read using a file, and vice versa. It's very useful for use cases where sometimes you have to expose your storage to an object interface and then read back later using a file because all your tools are file-based. So when you process something, when you want to run antivirus, when you have to do search, file-based utilities exist, but not object-based. But you don't have to. You avoid the copying back and forth between the storage islands because we have both. It has a very modular, stackable architecture. By that I mean it's very easy to add a new feature to it. It's Vijay will be talking about it in a more detail about translators. So everything in Gluster, every functionality that you add to Gluster is a translator, which is a software module. So you want to encrypt data, you add an encryption translator. You want to add multi-tenancy, you add a translator. You want to add replication, you add a translator. So that makes it very amenable as an open source project where a developer can come in, learn very quickly how to code, and it's all C, and basically add translators and functionality, and basically we get a lot of so it's right there in the sweet spot of where Red Hat operates very well. It's an open source project which has a framework that's extremely amenable for extension. The data is stored in Gluster actually, or Red Hat storage in a native format. So Red Hat storage by itself does not store any data. It's stored in actually the XFS file system. So if tomorrow, if you decided to walk away from Red Hat storage, no problem. You can still read the data. It's all in XFS. So we don't lock you in. It's all there. And there's no metadata server, which I talked about. So we use an elastic hashing algorithm to spread the files across different servers, bricks. And so there is no concept of first I have to go to the metadata server to fetch the location of the file and then go. So you can directly hit basically the file. We just know where the file is. So that gives us a leg up over many other scale-out architectures out there. So with that, I will hand over the mic to Vijay, who will take you through the next few slides where we talk about some of the technical aspects of it, and then I'll be back when we talk about productization.
Thanks, Shayan. So now let's take a look at the Red Hat storage technology stack. Let's go bottom up here. So at the bottom, you see the familiar Red Hat Enterprise Linux stack. So what Red Hat storage is built on is essentially the storage stack of Red Hat Enterprise Linux. It's basically RHEL 6.2 plus XFS. So along with that, we derive some of the other subsystems of RHEL, like the network stack, logical volume management, which could at a later point in time act as a foundational aspect for snapshotting. So on top of that, you have the Gluster layer. So till this line, this comprises the server side of the stack, and here is the client stack. The Gluster layer on the server provides you capabilities for management. That's the familiar Gluster CLI, I mean, if you have played around with Gluster. And a set of translators which perform certain functionalities. So how many of you are familiar with the notion of translators? Okay, I see a few hands. So translators are nothing but modular units that are essentially stacked together to build a Gluster process. So as Sayan mentioned, you could stack up a compression translator, an encryption translator, and the resulting effect of that is that you would have your data compressed and encrypted. Supposing you don't like encryption, you can take away encryption and you just have compressed data. So that's how Gluster is built on. It's completely modular and it's completely stackable. You can stack replication on top of distribution or distribution on top of replication. I'll come to that. So that's essentially about translators. So at the top, you see the various presentation layers or various access protocols. So you have Fuse, what we call the Gluster native protocol support. You have NFS. Again, it's built upon the Fuse or the Gluster native access is built upon a translator stack. We also introduced with RHS 2.0 a Swift-based access to the storage pool. Swift, for the uninitiated, is OpenStack's storage layer, and we borrowed the presentation layer from that and married that with Gluster storage. On top of any of these access protocols, you could have your user applications or QEMU or any of that to get your applications going. Now let's look at some basic Red Hat storage concepts. So everything in Red Hat storage is a volume. So a volume is a namespace that can be mounted. So what does the volume comprise of? Volume comprises of something known as bricks. So each brick is nothing but an export directory within a Red Hat storage server. You could have multiple bricks per Red Hat storage server. Now let's look at some of the volume types or use cases of these volumes. Basically, you can have a distributed volume, which means your data would be distributed amongst n Red Hat storage servers. In this example, you see 3 files which are distributed between 2 bricks or 2 export directories on 2 different servers. For example, file 1 and file 2 are on export 1 in server 1, and file 3 happens to be in export 1 directory of server 2. So when this is mounted, you get a unified view of these 2 directories. So you could have, from the mount point, you'd be able to see all the 3 files. So this is highly scalable. So we support up to 64 nodes. And if you have storage attached to all those 64 nodes, all of that could be unified and presented as a single namespace. Now let's look at replicated volumes. So as the name indicates, all replication does is replicate data. Over here you see file 1 and file 2. So whenever files are created from the mount point, files would be created in both bricks. If the replica count of your volume is 2, if it's 3, you will have to provide an additional brick, and 3 copies of your files would exist. Replication provides you high availability and guarantees against server failures. Say even if one of your servers goes down, that would be transparent to your applications and they would continue to work unhindered. And once your server comes back online, Red Hat storage takes care of self-healing or healing the updates that were performed on the other server while this server had a downtime. Now, I talked about replication and self-healing. So let's look at how it actually works. So we provide a highly consistent synchronous replication. This is a slightly dated slide, so I'll tell you what additional things we've done in the recent past. So whenever a file has to be updated, the first thing the replicate module in Red Hat storage does is hold a lock on the object. So this lock is held on both node A and node B, where the replicas reside. Right now you are seeing only one lock being held, but essentially a cluster-wide lock would be held for operating on that object. So once the first lock is acquired, we go about acquiring the second lock. At the same time, if you have client 2 trying to operate on the same object, that would be blocked because the lock is now held by client 1. So once the lock is acquired, we go about doing something known as pre-op. So we don't go about updating the file directly just because we've held a lock. Pre-op is nothing but changelog, or essentially state information about this transaction being maintained in the object that's being modified. So that is performed in the pre-op phase, so that at any point of time, if your node goes down during a transaction, we would exactly know what needs to be healed once, say, node B comes back online. So that is driven through this pre-op and the changelog mechanism. Once pre-op is done on all servers, the actual file operation, be it writing, so reads, we don't hold a lock for reading. This is only for modifications. So the actual modification takes place on both servers, on both node A and node B, and then we go about erasing the changelog or updating the state of the transaction, and which essentially means that it's been successful, or it's failed in node A or node B and it needs an update. So that's done. Once that's done, we go about unlocking the object on all servers, and as soon as that is done, the lock that was blocked here from client 2 gets an acknowledgement, and it goes about doing this same set of operations. Yes, please. So that depends on how your update is. So if it's for a region, I mean, it's for that region, and there are various variants. I mean, so in some cases we hold lock on the entire object too. Yes, please.
Can this replication work across data centers? And if so, what's the distance limitation?
So this is highly latency sensitive. So we recommend this to be used in a local area network. So for replication across data centers, we have a different model, and we'll talk about that later. Yes, please. Sorry, what was that? So we hold a lock on the parent directory, and we go about deleting the file.
Any more questions?
Okay.
Okay.
So I'll leave to Sayan now on more about productization.
I'll go through the productization part of it, and then change over to Vijay for some of the Res 2.0 unique features. So what can you store in Red Hat storage? You can store, documents, file, folders, videos, images. You can store all of that. Log files, RFID data, long tail objects. So it can hold, all kinds of unstructured data. So when you think about, photos, pictures, files, and soon to becoming VM images, Red Hat storage is usually a good solution. This is how we productize it. So if you say, changed your mind after seeing our presentation and thought Red Hat storage is something that you'd like to order, what do you get? You basically get in a single SKU, which bundles Red Hat Enterprise Linux, XFS, the XFS file system in Red Hat terminology, we call it the Scalable File System add-on, and GlusterFS distributed file system, as well as a Red Hat Storage Management Console, all in one SKU. So it's all packaged in one SKU. And the customer sources the server where you want to run it. So what you buy from Red Hat is the software, ISO or AMI, which is pre-integrated, pre-verified, and ready to run. Customer gets the hardware, or you can use it on Rev, VMware, or as an AMI in Amazon. So it's the right-hand part is what you worry about. The left-hand part, we give it to you. And while you worry about the right-hand part, we also have some recommendations on which vendors to buy your server hardware from. The reason we recommend these vendors is because we support and test on these platforms, so we want to make sure. Our requirements are not very stringent. We basically are expecting 2-socket Intel or AMD servers that are either quad-core or hexa-core and comes from these vendors. And we have a few more requirements on RAID capabilities and data protection. So we have a KBase at the bottom that details what. So you can basically choose, whichever vendor. And I'm thinking most of you probably use one of these vendors out here, and should not be an issue. And we'll keep updating this list over time so that you have a bigger hardware pool to choose from. And we have 2 variants of the product right now. We have what we call a Red Hat storage server for on-premise. This is the one that you deploy on-premise in your local data center. It comes as an ISO, and you can put it on a physical machine or a virtual container. So that's one of the incarnations. The other incarnation is what we call the Red Hat Storage Server for Public Cloud. Today, it runs only on Amazon Web Services. You get the AMI. It's uploaded in all Amazon regions, so you can basically access it anywhere in the world. So those are the two big incarnations. In addition, we have a marketing product which we'll call the Red Hat Storage Server for Hybrid Cloud, which basically gives you an equal number of subscriptions for the public cloud and the on-premise version, so that you can just get that and set up a geo-replication session from your local data center to Amazon if you wanted to. so that instead of buying or ordering two different things, you can just get that. The other thing that currently is in technology preview mode in Red Hat Storage 2.0 is our management console. So we do have a graphical user interface that we have that comes with the product too. And eventually, it also basically it offers REST APIs as well as a subset of the functionality that is in the Red Hat Storage CLI. But the plan is to expose all of the functionality that we have today in the CLI through this and more. So for people who have basically would like to use a console to manage the Red Hat storage deployments, this is a good answer. And there is no limit to the number of storage pools you can actually manage with this, but we recommend up to 4, just for ease of use. And this one, sorry, I'll go back to, and this one's currently only available for the on-premise variant. We'll soon bring it for the cloud variant. Just another thing. So Red Hat Storage 2.0 focus. Now, as I told before, that we just released Red Hat Storage 2.0 yesterday. The announcement went out, the G announcement, and this is what we focused on. We acquired Gluster in fall of 2011, so in October. And after we acquired Gluster, we inherited a product from Gluster where we kept that on the market for a few months for continuity reasons. But this is the first big launch from Red Hat. And the things that we really worked hard to get out the door before we released were, we focused on services for unstructured data, and Vijay will come into the details on what exactly we did there. We focused on making it enterprise class because Red Hat is now backing this product. It needs to be solid. It needs to work really well. Needs to be supportable. Needs to be upgradable, and needs to be supported worldwide. So we focused a lot on that. We also focused on making it a really good NAS alternative for file sharing. So it is one of its core strengths, and we made sure we did a good job with it. So that's kind of the big 3 foundation pillars on which we worked on REST 2.0. And then I'll hand the mic over to Vijay to take you through what we exactly did.
Okay, so now let's look at another use cases before I get to what's been done in Red Hat Storage 2.0. So we had a question on how do we achieve replication across sites or across geographic regions, and Red Hat Storage geo-replication is the answer for that. So you have a file-centric storage use case around disaster recovery. Say, assume you have 2 sites, Site A and Site B, and Red Hat Storage geo-replication can replicate files across these sites. Right now, it's unidirectional in the sense that it operates in a master-slave mode. You would have a designated master, and this could be the slave. A master can have any number of slaves, and it need not be between just 2 sites. It could be between your on-premise deployment and your cloud, or between clouds. It supports all variants. Red Hat Storage geo-replication addresses all these needs. And supposing if disaster were to strike one of these sites, we have a failover and failback mechanism so that an alternate site can take over as the master, and that can receive writes. So that needs some cooperation from your application logic to get it going. Okay, so Sayan talked about what we've done since the acquisition and what's got into RHS 2.0. So the primary focus was on hardening and robustness, upgradability, and supportability. Around hardening and robustness, we introduced something known as proactive self-heal. So self-heal, as I referred to earlier, is about self-healing data that was received by a storage server because it was offline. And in the past, we required the file to be accessed or the objects to be accessed before self-healing could be done. So we've now brought in an improvement for doing this process of self-healing proactively. As soon as the server comes back online, the proactive self-heal kicks in and it goes about synchronizing files between the replica sets. We've done some geo-replication enhancements that I alluded to in the previous slide. Rebalancing comes into effect when you expand your storage cluster. When you add more capacity, when you expand horizontally, you would want to move out data from your existing nodes to the new nodes. So we've improved our rebalance algorithms. Rebalance now is completely distributed and derives the benefits of a scale-out cluster. So we brought in support for highly available NFS, so there is no single point of failure. Your NFS head wouldn't be the single point of failure, so that's been addressed. We worked quite a bit on upgradability to ensure seamless upgrade from RHS 2.0 to 2.1, which means that your applications wouldn't notice whenever you decide to upgrade from RHS 2.0 to 2.1. So for this to work, obviously you need replication, and you could perform a rolling upgrade to achieve a seamless update. In terms of supportability, we've integrated with the familiar, for those of you who used RHEL, the source report and the ABRT set of tools. We've introduced monitoring commands, the cluster volume status, which provides you detailed status of how healthy your cluster is. We've improved logging and added more supportability for logs. In terms of provisioning, we've enhanced remove brick to move data onto existing bricks before it goes out of the volume. Which means if you're decommissioning a server, data that resides in the bricks of the server could be moved to other bricks in the cluster, and once that's done, you could go about decommissioning a storage server. We've also introduced volume lifecycle extensions, which means you can improve upon our manageability. So if you want an alert to be sent out, say whenever a volume is started or whenever a volume is stopped, you could leverage the volume lifecycle hooks or volume lifecycle extensions mechanism for doing that. So there are various things which you could do around this interface. So we alluded to support for unstructured data. So let's see what's there in RHS 2.0. We've introduced unified file and object, UFO for short, nothing to do with unidentified flying objects. So we've married or brought together object and file storage together. Object storage provides you API-based access to Gluster. You could change your applications to leverage these APIs and talk to Gluster. This works over the internet, so it's not just limited to a LAN. The API is completely RESTful in nature. You basically do a series of gets and puts to talk to Gluster. And this works on, if you're familiar with OpenStack Swift, you would be familiar with notions like containers and objects. Containers are nothing but placeholders for objects. Containers contain objects, so that support is there, and objects could be seen as files. As Sayan mentioned, you could upload an image through the object interface and go about editing with your favorite photo editor through the NAS interface. It's completely standards-based. It's based on OpenStack Swift and provides NAS interface through various access protocols like NFS, CIFS, and Fuse. We've brought in improvements for access from Microsoft Windows. We've got CTDP support, again for solving a single point of failure. Okay, now I'll pass it on to Sayan for tech preview and other aspects of Red Hat storage.
Yeah, thanks, Vijay. So basically, while we took a lot of functionality, I released a GA Red Hat Storage 2.0. We have a few other very interesting features that are currently in tech preview, and we'll GA them over the summer and fall as we feel we are ready to do that. One of them being a Hadoop plugin. So this would enable you to use Red Hat storage as a replacement for HDFS in a big data environment. The Red Hat Storage Console, as I mentioned before, is currently in tech preview, but as we mature it over the summer and fall, you'll see that this is much more comprehensive than it will be right now. It's only a subset of the functionality, but given we started the project a few months ago, we are pretty amazed of where it has come today. So I hope to bring that out in full supported mode pretty soon. Support for read-only volumes. We do have the concept of read-only volumes in Gluster now, but it's in tech preview. Again, that's something we're looking to improve upon. And InfiniBand support. We actually also support InfiniBand in addition to TCP/IP as an interconnect protocol, as a mount protocol. But it's in tech preview, and again, looking to take that out of tech preview mode as soon as possible. But they're very promising and interesting features that are lined up as tech preview, and it's basically, if any of you are interested in testing these things and give us feedback, you're very welcome to, because that will help us mature these features and get them out of the tech preview mode. So we always welcome people to do that. We have a bunch of reference architectures that are available with the product right now, and they will again be revved a bit over the next few weeks, but we have an installation and configuration guide, very detailed guide on how you go about installing and configuring it. It's above and beyond what Red Hat storage documentation does, and it's very nice. It also provides tuning hints, which people always appreciate. We also have a nice white paper on how you deploy this on Rev or VMware to serve out storage. So that's available too. We have a performance and capacity planning guide, so you can use that to figure out how many servers you need, what's the best client, what kind of files are good for what clients. If you use random access, which client should you use? If you use sequential access, which client should you use? And all of that is also there. Storage resident applications. This is a part of a tech preview feature. We have published a white paper that basically lets you get a feel for what it will mean when you take your application close to the storage using Linux containers. Now, Linux containers itself is in tech preview mode in Red Hat Enterprise Linux. So this is something for you to kind of play with and see how you like it, and give us feedback again and see what we can do to get this out of this tech preview mode. But this helps you to actually get a taste for what it means to take your application close to the data. Unified file and object, we have a paper for that too that will help you figure out the APIs that we use to put and get objects. That's coming soon. We should have it in a week or so. So that's that, and that's my next slide is just a glimpse of the roadmap. And again, I want to ask you, all of you, to come to our next session, which is at 4:50 p.m. in room number 306, where we'll go through a detailed roadmap presentation and the coming attractions, basically for Red Hat storage. What we have today for 2.1 primary features is we'll definitely enable Red Hat storage as a VM image store for Rev. So that's goal number one. We plan to support multi-master geo-replication. So what we have now is active passive geo-replication. So you have a master site and a slave site, and they replicate, and you can all fail over and fail back between the two. But what you don't have is the capability of writers on both the sites who can write simultaneously, and then everything is eventually consistent based on some conflict resolution policies. So that's incredibly powerful. That's coming. Snapshotting, yes? No, we'll have to wait for. We pondered with that idea, but then we thought our best foot forward will be to use the GlusterFS Fuse client to mount the Rev storage pool or the Red Hat storage pool from Rev. So we'll start with that as opposed to NFS mounting from Rev. It's just, I think when it comes to VMs, the behavior we see are VMs are large files with lots of random IOs and timeout sensitive, and our GlusterFS Fuse client is definitely a better fit than NFS. And again, we don't want to play with people's data. This is important. This is production. So we want to start with the best architecture as opposed to let's do something now with NFS and look at GlusterFS. So we would rather do that, do something well as opposed to do something for the sake of doing. That's the way I'd put it. Snapshotting, yes. Sure.
It seems like the translator system for your place to put something like the
Sure. Come to our session at 4:50, room number 306. So I don't want to steal the thunder from that session. So we'll have Doug Williams from Red Hat Storage CTO office who will lead that session, and we all will be there presenting things. Snapshotting is again, it's pretty much table stakes, and our primary use case for snapshotting is a snapshot in your backup. So we definitely plan to address it. It's not there now, but we definitely highly recommend that you set up your Red Hat storage volumes with LVM so that you can take advantage of this feature.
One other question. I was wondering, can any local device be used as be used as a break, essentially, to supply to the storage?
When you say any local device, you mean disks in the server, JBODs? Yes.
Now, what about appliances that you might connect to using something like AOE or iSCSI?
Yeah, so AOE and iSCSI are something that we are not planning to address right now in near term, but we'll definitely have a look at it in the medium to longer term. Right now, what we want to make sure is we do everything with JBODs and direct data storage right, and because our primary market for this storage is that, and then we will move out to the other protocols that you're talking about. So I think our foundation this year, we're working really hard to make sure our foundations are all correct, and we'll take over AOE and iSCSI at a medium to longer term.
But if drivers make them appear as local devices on the servers,
Yeah.
then I guess I'm wondering why couldn't that work?
The thing is, as soon as you expose, iSCSI, you have to take care of the failovers of LUNs and things like that. So that's something we are working on with Gluster, not yet baked. So Gluster is, we don't recommend using Red Hat storage with a SAN backend today, because that's not where we want to go with this product, because people whoever our customers and prospects who come to us, and try to use it, are trying to get away from the whole SAN model in general, because that's where they see the value. So if you're wanting to use a SAN, for a temporary period of time because you don't have the budget to get DAS servers, we can consider it. But our whole point is that's not where we need to go in the long term. So any of the SAN related features, iSCSI, it's like AOE, that's something we will consider, but in a medium to longer term, as opposed to our immediate market and needs, which is direct added storage, JBODs. So Snap again is coming. So that's pretty much it with our presentations today. So before we leave, so what is it in a nutshell? We've got a storage server software that's installed on commodity server and storage hardware. It's extremely flexible and easy to use. You create a powerful turnkey, massively scalable, and highly available NAS in minutes, and you can use it anywhere. That's if you had like 2 or 3 takeaways from this session, that's the way to look at it. And for people who are familiar with Red Hat Network, I have a quick slide that shows you how it is delivered. the channels and the stuff. So it's, again, these slides are obviously available at the JBoss Red Hat Summit webpage, so you can download them. But this is what it looks like in RHN, if you're familiar with RHN. Sure.
Earlier you talked about the components and capacity guide. Where is that located?
So if you go to, so Red Hat Storage now has a customer portal. It's access.redhat.com. If you go to access.redhat.com, right in the center you will see Red Hat Storage. You click that and go to, and there's a tab called Knowledge and Resources. If you go there, all the reference architectures are available. So it's, or you can go to the access.redhat.com knowledge base and look for Red Hat Storage. So that's the other way. Yeah.
You mentioned just about every server vendor in the world. So you certifying them, or is it a marketing relationship? And the other question is, could you use multi-service for two different companies?
Let me answer your first question, which is, are you having a service? The question that we are reusing the rel cert process. So if you see the knowledge base article that actually describes what is a compatible Red Hat storage server, you'll see that it's mandatory to use a server that's certified with rel 6, and then we take a subset of that. So it's 2-socket, it has to be from one of those 7 or 8 vendors, it has to be. So we don't have a specific, Red Hat storage specific cert process, but what we do have samples of some of these servers that we run our tests on. So it's not that, so if you picked a vendor, say, IBM or Cisco or HP or Dell, and if it's a 2-socket server, and if it's in HCL, right, hardware compatibility list, and it has the right, RAID data protection capabilities, it's approved. That's the way to look at it. And your second question was?
Mix.
Yeah. We are not recommending it right now, but if you have a specific reason to use that, please get back to us and we'll review the configuration.
Did you say that they were just AMD based?
No, Intel and AMD. And again, if you look into my slide where I showed the 8 vendors, there's a knowledge base article link. Just click that and it will take you to, and you don't need a RHN subscription to view that. It's open to everybody and it has all the vendors listed. And we're looking at Intel Nehalem EX and beyond, and the AMD equivalent for processor. So nothing exotic. It's your vanilla servers that you get, you can buy, and that's it. Go with it.
Yes, please.
Yes.
So, is it a way for migrating the existing storage domain from Rev 3.0 to the RHS provided Rev-based storage?
Right now, we don't. So basically what you're saying is currently Rev supports three storage domains, iSCSI, NFS, and FC, right? So what you're asking is will there be a way to migrate those image stores to Red Hat storage eventually? That problem is not anything different from migrating your data from an existing infrastructure into ours, right? Basically, fundamentally, it's the same problem. So we plan to provide, yes, our Red Hat professional services to enable you to migrate data from your existing environment. That should just include that. So it should not be anything special in my mind.
So the integration that you are talking about in the Rev, so it is with the 3.2, Rev 3.1 or Rev 3.2?
So Rev 3.1 will have the initial integration using the GlusterFS Fuse client. Rev 3.2 will take it a notch higher, where we will use native QEMU integration, where we'll bypass the Fuse and go directly to the Gluster bricks from Rev. So that will be even more powerful.